Thank you everyone for taking some time to attend our webinar, Flexible Advantages of Laser Heat Treating. It'll be about a 20-minute presentation given by Todd Glenna and Craig Swanson, and then we'll have a question and answer afterwards. We will be recording this session, and a presentation will be sent out to everyone later this week. If you have any questions, please feel free to type them at any time down below in the Q&A section. We will answer those at the end of the presentation. The agenda, we will kind of go over the basic heat treating information, part sizing, machine examples, common delivery or common approaches for beam delivery, material selection, and application examples. Your presenters today will be Todd Glenna. Todd has worked at Preco since August of 2018, and he was a sales manager for a few metal stamping houses in the Twin Cities before coming to Preco. While not at work, Todd likes hunting, fishing, riding motorcycles, and spending time with his family up north. Craig Swanson has been with Preco for over 20 years, and he started as a project manager in the metals division, and now is a key account manager in the contract manufacturing division. Craig's focus is on, but not limited to, advanced energy storage, agriculture, heavy industrial, aerospace, and defense industries. Todd and Craig, I'll let you go from here.
Thanks, Gwen. As y'all know, I'm Todd Glenna, and this is my counterpart today.
Hello, I'm Craig Swanson.
So I'll kick off the webinar to get things going here. So the majority of laser heat treating that is done in the industry is transformation hardening. Lasers can also be used for tempering and annealing, but these will not be covered in this presentation. Transformation hardening in its basic form is heating the desired surface red hot and rapidly cooling it to transform the grain structure to martensite. Lasers can temper localized areas to make particular zones more ductile. Annealing can be done with the laser as well, but again, it's only done in localized areas. If you are heat treating today with induction, flame, or electron beam, lasers may be an alternative for you. Heat treating is achieved with either energy or time. Typically, to achieve greater case depth, the cycle time goes up as seen in the picture above. This is a very basic example of what heat treating looks like. The picture on the left shows a small amount of time and has what appears to be a shallow case depth. The picture on the right shows a longer amount of time and what appears to be a deeper case depth. This again relates to time and energy. This is a typical heat treating track profile, You will see the elliptical sides in this picture. Keeping that in mind when you're looking for a certain case depth, make sure you have enough width in the optic selection to accommodate that. Flexibility of the laser to do small or large parts makes it a useful tool. The speed in which the changeover can happen also makes this a great system to use. The picture on the left is around 4 to 5 inches in diameter, and the right photo is of a very large part as seen with the scale of the person. Flexibility of materials that can be heat treated by the laser are listed above. This is just a small list that we have put together. These are the common materials that we see and also heat treat in our facility. The key takeaway here is carbon content and mass for self-quenching, so that liquids are not needed to cool that part. This is just a small representation of systems we can provide. Both are very easy to load and unload. The machine on the left is the Class 1 machine. This means that the machine will not allow the laser beam out of the unit. Because of this design and designation, you can put this machine in many more places in your factory. The machine on the right is a Class 4 machine. This machine is wide open to the operator and the people around them. All employees will need to wear special glasses due to no safety enclosure like the photo on the left. You can see they're both very different. I want to reiterate, both are safe machines. It's just the safety precautions that are needed when using each of them. Hence the designation of Class 1 and Class 4. Another unique tool is the zoom optic. It is adjustable in the X and Y direction. It is also capable of adjusting on the fly. The center photo shows a basic track from narrow to wide and back to narrow again. The photo on the right is of an actual zoom head, and the overall length is about 18 inches. The photo to the left is showing the sizes the zoom head can adjust to. The measurements are in millimeters. This particular optic is great for the people who want to be set for current and for future use. It seems as if requirements are always changing, and this optic is ready for that. We have some case studies we're going to go through. Craig will hop in to do that.
Hello. So we've got 4 case studies, and all of them Preco has worked on, whether it's for our contract manufacturing division or for our laser equipment division for our customers. All of our customers came to us with things they were trying to solve on their parts. And this is a good example of the flexibility of laser heat treating with lasers. The first one that is on the slide is we worked on rotary mower blades used in the agricultural, turf care, lawn care industry, a fairly consumable part. And they are 1/4 inch thick. This particular variant was a 1/4 inch thick carbon steel. They were already formed to shape and they were sharpened. And then they were looking for options to harden that sharpened edge, approximately a 1/2 inch wide band going down to the sharpened edge, approximately 1 millimeter deep or 40 thousandths. And the surface hardness in the mid-50s Rockwell C. And that's basically to reduce the frequency of maintenance on the blades, i.e. sharpening. The blade will see a lot of abrasive conditions, especially in the southern US where they're in golf courses, for example, with a lot of sand. And we effectively developed a laser process that we could get that 1/2 inch band to the full length of the cutting edge without melting the sharpened edge and not melting that tip, which is was a plus. The other thing is there was no secondary operations needed as far as secondary machining or sharpening. And with all of these, you'll see that. And you'll also see that, like with this one, there's many part numbers throughout their series of blades, and they needed to reduce setup time. So they didn't want to change tooling, so we could make universal tooling to put various part numbers on. And then with the controller, changing the computer program, you could go from part to part with a CNC controller change rather than a tooling change or having things such as induction coils or such. So it was a very successful development and production program. And the next component that we worked with is a much thinner material, approximately 60 thousandths or 1.5 millimeters thick, a higher carbon content material. But with the thinner material, it's a challenge because typically we won't have the mass to dissipate the heat to self-quench, as Todd was mentioning. And on this case, we actually developed a process where we could come in from the edge of the material and perform a heat treat along the entire outside edge of the bar where the chain rides on the bar. Because these particular bars, not like the picture, were not used in the forestry industry or wood cutting industry. They were used in a highly abrasive construction industry cutting cinder block or concrete walls. So for the concrete saw industry, they needed to increase the service life of the chainsaw bar. And the chainsaw bars are relatively expensive for this industry because of all of the channels for cooling that run through them. Preco worked with the customer. We developed a laser process, again, that would not need secondary quenching operation, and it did not need a secondary machining operation to smooth the edge. So we don't have any melting on that edge, but we achieve approximately a hardness of 60 Rockwell C. And this one, we bring it to about 60 thou deep also down the edge of the bar. And it has been a very successful program for many years for us and for our customer. And again, this program, I would say, has 30 part numbers, and we are able to use a universal tooling. And with programming changes on the CNC laser system, we are able to go from part to part without tearing down tooling and setting back up and requalifying. We're able to make computer program changes to go from part to part, which again is a good indicator on how flexible using the laser is for heat treating on various parts. And I would say we heat treat is a rule of thumb from small thin metal parts that you could fit in the palm of your hand to large machine components that may weigh multiple tons, that are the size of a small recreational vehicle, for an example. The next slide is a consumable part, and it's for the agricultural industry. It is a highly abrasive environment, and it has a high volume of components that run over the top of this wear plate. It is specifically a wear plate, and we do a number of them at high volume. When the customer came to us with this part, it is a high carbon material, which, as Todd mentioned, is mid to high carbon is a requirement in many of these instances. This is a relatively thin material also, which is approximately 60 thousandths of an inch. The issue with this one is we're putting on a 1/2 inch wide band heat treat that is approximately 6 inches long on this particular part number. And with that, there is not sufficient mass to self-quench the part. So Preco worked with our applications team, and we were able to develop a process where we can quench the part in process. And it has been repeatable, it has been cost effective, and it puts on a very effective heat treat band in the wear area of this part, which because it's an agricultural part, and it does require field changes at time, it has expanded the usage of the single part and reduced downtime in the field. We've produced in the area of over 1 million of these parts, and we see less than 1% scrap. So it's very repeatable. And again, there is no secondary operation required, which would be almost impossible for this part to smooth the surface. So we are not melting the surface, and it's on an inside radius, which added another challenge.
So it's a curved part.
Yeah, sorry.
To be honest with, that's not a flat part. It has a radius to it where the heat treat follows the whole flat to radius to flat.
And then the last example is actually a thicker. They range from 1/2 to 1 inch thick of a cast iron or powdered metal component, which is a ring that goes into a hydraulic actuator assembly for hydrostatic steering. We've been heat treating in our contract manufacturing division these particular components for more than 20 years. We have produced hundreds of thousands of them. They have in excess of 15 part numbers for this particular product line. And all of these components have localized heat treating areas. None of them have an entire heat treat. And this is another example, just like the last example, that it's a very tight tolerance heat treat area. They need that wear resistance in that area because it's a contact with other components. And there's a high level of movement between the parts, and they needed a longer lifespan. So we're able to, in this particular component, whether it be cast iron or powder metal, to get an effective case of between 10 and 30 thousandths of an inch thick, approximately 1/2 inch on a single pass to 3/4 to up to 900 thou wide on a dual pass for the heat treat. We have other larger components that they may need the entire OD of something heat treated, where it could be in excess of 12 or 24 inches wide, and then what we call is barber pole, where we're overlapping, or we'll do concentric rings around the OD. And there is a small overlap where we'll have it tempered back some, but other than that, we can pretty much do the targeted area of whatever the print calls out, as long as we have certain characteristics met for the part. This particular component has, as I mentioned, it's been over 20 years. They've been in the field for that long, and we have not had unexpected field failures, and they've increased the lifespan of the component. And it's a good example of medium carbon, high carbon, cast and powder metal components of various thicknesses, various geometries, various targeted zones of heat treat with depth and hardness, and pretty much gives a good broad spectrum look at the flexibility that we can do with our laser systems or in our contract manufacturing division. And we also have our applications development team that is on the front end of all of these programs that drive the development of the laser heat treating processes that our customers come to us with. I think that's pretty much all I have.
Okay, real good. Thanks, Craig. All right, let me adjust the camera here for my height. Craig's quite a bit shorter than I am. Yeah. So this ends the webinar. Something we'd like to probably bring up is there's multiple sides of Preco. I work on the LED equipment side, specifically in the metals area. Craig works on the metal side, on the CMS side of it. And then we also have another facility in Lenexa, Kansas, that does some presses and some rotary presses. So we have multiple locations, just to kind of give you a little flavor for what we do here. So I'm going to exit out of this, and we're going to move on to the Q&A portion of this. All right, we do have some questions on the board here. The first one is, how big of parts can I run on your systems? You're not really limited to answer that question. We can build a system to accommodate what you need. We can custom build that. If you do have sizes you're wondering about, you can always reach out to us, myself, or Craig, ask us, if you have a part that's a certain size, send it to us. We can let you know if we have a system on the floor that it could accommodate. We do have some somewhat standard systems that we make that they may fit into, but we can answer those questions for you with a phone call or with an email, put it that way. Another question here is, if we have sample parts we would like to try, can you help us out? We sure can. We do this all on a case-by-case basis. It also depends on what we have available on the floor for us to possibly go down and put your part on and try out. And if we have the right tooling and the right optics to do this for you. But yes, we can help you out to some extent and hopefully give you exactly what you're looking for. Another question here, does the feature needed heat treating need line of sight for the laser? I'll let Craig probably respond to that one.
Yeah, it does. It's a light beam. So if we have access to have from our laser heat treating head to the surface that needs the actual heat treat, that is what is required. We will have instances where that feature may be hidden. And if we can't have line of sight to it, we're not able to do it with the laser. And there are instances where we have ID of tubes, for example, where people ask us to heat treat or clad, and that is possible. They do make, depending on the size of the ID and the depth of what needs to be heat treated, they do make specialty heads to get into the ID for both heat treating and cladding that we have used. And if it's a large enough ID, we can come in at an angle of incidence. And again, as Todd mentioned, with our applications development group and our engineering groups, we can look at those prints and we can assess if we need a special head to do the application, or if we're able to come in, again, as I mentioned, at an angle of incidence to get the effective heat treat needed. It does not have to always be normal with the part. We can come in at an angle.
All right, we got another question here. How do you keep the sections from warping during the heat treat process? Thin sections. So I'm assuming you're probably referring to the sheet metal that you saw, I would have to think.
Yeah, so for the chainsaw bars, those are fixtured solid and they have enough structure to them. They're wide enough that the laser heat treating is applying the heat at a relatively rapid rate along that edge. So it is not warping the entire bar or the heat treat area. For the other wear plate, as we mentioned, the radius one, when that comes in, we restrain that part in a tooling with the active quenching, and that dissipates the heat rapidly enough that we're not having excessive distortion on that, and that has to fit into another assembly, so it is sensitive to distortion. And again, a case-by-case basis, depending on material, what the actual form and function of the part is, and if there's inherent stress in the part. And there are other programs where we may heat treat it and then have to put it in to an oven for some basic tempering.
Again, we referred to it earlier in the webinar. The mass of the part will hopefully self-quench, and that's not always the case. Now you're asking about thin, but as Craig was discussing, that metal is able to self-quench those particular part, the one particular part he was talking about, not the one that we have to use some liquid cooling on. Does anybody else have any other questions? Oh, looks like we have one. The active quenching is very interesting. Thank you for elaborating. Thin parts are a challenge. Yes, they are. That's very true. Takes some special things to do, but we've done quite a few and we've been successful. So we can appreciate that comment.
All right. If nobody has any other questions, we will go ahead and conclude the webinar. So if you end up with any other questions or need to reach out, go ahead and reach out directly to them. And like I said, we will send a recording of this webinar to everybody who is registered here today at the webinar. And you can review it or send it off however you'd like. So thank you, Todd and Craig.
Thank you. Thank you. Appreciate it.
Thanks, everybody.